We are on FRQ topic number 4. These are data and table questions. So every one of these questions has a table with values in it. Some of these are with a calculator, some are without. So you're given a table of data. Usually time is going to be your independent variable, but it might be some other independent variable. And you'll either be given an amount or a rate function. So you have a closed interval given by the table usually with an initial amount typically at time 0. So you need to be able to do several things. You need to be able to estimate the derivative of the function given in the table. You do this using the closest 2 points, the closest 2 times to the time that you're given in the derivative. Okay. Be able to estimate the integral of a function using a Riemann sum. So left, right, midpoint, trapezoid, be able to use all of those. And remember that the Riemann sum only gives the approximate integral value. It does not account for anything else asked for. It only approximates the integral. Be able to tell if your approximation is an over or an underestimate. Okay. Draw it out, show the type, prove it to yourself, and then determine which it is. Absolute extrema, again, that's been in almost every one of these topics so far. Use a candidate's test for those. Explaining the meaning. We've talked about this quite extensively. Be able to explain the meaning of a derivative. Be able to explain the meaning of this expression. Remember that when you have 1 over b minus a, integral a to b of the function, that is the average value of that function. That's the average value of f from x equals a to x equals b. The integral of a derivative. The integral of a derivative gives you change in f. Okay? And distance traveled by a particle. Okay, distance traveled by a particle, absolute value of velocity. Okay. All right. So remember to give your meaning in the context of the problem. Don't say it's f. Say the meaning of f. Okay. And units on time and units on whatever you're describing. Okay. Use IVT or MVT. If you're given a table, prime opportunity for them to ask you IVT or MVT. There might also be an EVT question, but IVT and MVT, those are more prevalent. Okay, and be ready to get a different function in part C or D. They might give you another function, a third thing or second thing. So that might be a completely type of question. So just don't be rattled. Just do what they tell you to do. Alrighty. Let's take a look at FRQ, the FRQ from 2023. So this was a good one for KHS. Our average was 6.3 compared to the Texas average and the global average. This one was with a calculator. Okay, so clearly that's really high for us. Okay, a customer at a gas station is pumping gasoline into a gas tank. The rate of flow of gasoline is modeled by F. So this is almost like a rate in problem as well. It just happens to also have a set of data. So they're giving us the rate. Okay, the rate is F. Gallons per second. Okay, the rate of flow of gasoline is modeled by F. F of T is measured in gallons per second. T is in seconds since pumping began. Selected values of F are given in the table. So these are rates. Using correct units, interpret the meaning of the integral of F in the context of the problem. There should be a period after that. Use a right Riemann sum with 3 subintervals, and they give us the subintervals to approximate the value of that. So down here in part A. All right. First of all, what is the meaning of this integral? Okay. The meaning of that integral. So when you integrate rate, what do you get? When you integrate rate, what do you get? So this integral from 60 to 135 of the rate of flow of gasoline gives us the amount of gasoline that was pumped into the tank, because it's the integral of a rate in, it's the amount of gasoline that was pumped into the tank from time 60 to time 135. Okay, so that's what I'm going to say. Gives the amount of gasoline in gallons that was pumped into the tank from time equals 60 seconds to time t equals 135 seconds. Okay, remember the little acronym NUT, NUT, noun, units, and time. Did we include all of that? The noun is the amount of gasoline. Units, there should be two sets, gallons and seconds. And the time, 60 to 135. Okay? Now granted, in some of our descriptions, some of our explanations, the meanings, this T won't represent time. It'll represent whatever the independent variable is. Okay? So that's the meaning. Now we want to use the right-Riemann sum. So, right-Riemann sum is going to approximate this integral. It approximates the integral, right? I'm going to, because this asked us two different things, I'm going to go ahead and write that integral is approximately equal to, now here comes our right-Riemann sum, and we need to remember we're starting at 60. The table starts at 0. We don't want to start at 0. We're starting at 60. So 60 to 90, 90 to 120, 120 to 135, and we're not going to go to 150 because they told us to stop at 135. They even gave us those intervals. Okay, so we'll need to be careful with that. So we're using a right-Riemann sum. So the first ordered pair here, the first set of points are those two. The right F value is 0.15. So 0.15 times change in the time, 90 minus 60. If you want to, you can write that as 30. But that's the only simplification you can do in these problems. So that takes care of those two. Now we go to the next two, 90 to 120. 90 to 120, the right F value is 0.1 times the change in time. So 0.1 times the change in time. Again, if you want to simplify that to 30, that's fine, but that's the only simplification you can do in these problems. And then the last ordered pair, 120 to 135, the right F value, 0.05 times the change in time, 135 minus 120. And we stop right there. We have a calculator in this problem. This is a calculator problem. It was number 1 that year. But there is nothing to be gained by cleaning that up. So you just leave it. Go on. Be brief, be brilliant. Go on. Okay, part B. Must there exist already? When I see that, I'm thinking already IVT or MVT. Must there exist a value of C? When I see that, I think it's an X value. In this case, a time value between 60 and 120, such that F prime of C is 0. F prime of C. Since it's F prime and the table has F, I know I need the MVT here. Our justification is going to be using the MVT. Okay, so my mind shifts to MVT, and I think of, I need these three things. The last thing will be my conclusion. The first thing I think of as my basic conditions that must be true for MVT. And the basic condition for MVT is whatever function is in the table must be continuous on the closed interval and differentiable on the open interval. How do we know that's true? They told us that F was differentiable. So I'm going to say here, F is given to be differentiable. So F, name the function. Don't say the function. Don't say it. Name it. F is given to be differentiable. So F is both continuous and differentiable. We only need it to be continuous from 60 to 120, and we only need it to be differentiable from 60 to 120. But since it's differentiable everywhere, it is continuous everywhere and differentiable everywhere. Okay? That's the basic condition for MVT. Now we're going into the meat step. Okay? I need to find between 60 and 120, I need to find two F values that are the same. Well, it just so happens that those two are the same. Therefore, the rate of change between them is going to be 0. Right? Average rate of change is equal to instant rate of change in an MVT. Alright, so I can say that F of 120 minus F of 60 over 120 minus 60 is equal to 0.1 minus 0.1 over 100 minus 60, which is equal to 0. Notice in here, I did not use this. I didn't use it. That has nothing to do, well, it does have something to do with it, but that does not enter into this step. You want to show the average rate of change is this number. Do not say that that is equal to F prime of C. Don't write it. That comes in your conclusion. Don't put it here. Okay? Alrighty, now comes your conclusion. And in your conclusion, this is where we can repeat what we're trying to find, what we're trying to show, but get rid of this word must. Repeat all of this. So, there must exist a value of C for 60 to 120 such that F prime of C is equal to 0. Notice, you guys, that get into the habit if you do not write outside of the box, there will be on the actual test, there will be little instructions over here that say do not write outside the box. Okay, I didn't put those on my sheets, but they would be there on the actual test. Alrighty, that takes care of this part B. Now let's go to part C. Alright, the rate, notice that so far we have not touched our calculator. In part C, I'm pretty sure we're going to be touching our calculator. Okay? The rate of flow of gasoline in gallons per second can also be modeled by G of T. So this is also the rate of flow of gasoline for 0 to 150. Using this model, find the average rate of flow of gasoline from 0 to 150. This question is asking, does this student know the formula for the average value of a function? This is rate. Find the average rate. What is the formula for the average value of any function? 1 over b minus a, so 150 minus 0, integral 0 to 150 of the function, not its derivative, the function in play. So the function in play is g of t. Remember, do not rewrite the actual expression. Best case is that you rewrite it correctly. But what if you miss something? What if you miss a parentheses? Then all of a sudden your integral is wrong and you've lost a point when you could have just written g. I'm pretty sure you won't misspell g, right? Okay, so in we go to our calculator. I still have the last time I used this. Let me get rid of that. Okay. I think I'm going to take the time to put G in for Y1. Okay, so I'm going to type it in just like I see it, okay? Parentheses, fraction, T over 500, close the parentheses, cosine. The first parentheses is already given, but now I need another set of parentheses. So another parentheses, fraction, T over 120, close those parentheses, square, now close that parentheses. So it can look, if you want it to, it can look exactly like what it says on your piece of paper or on your screen or whatever. Okay? So now I'm going to go to my home screen. 1 over 150 integral math 9 0 to 150 y1 dx 0.0959. Remember, you guys, you need to give at least 3 digits after the decimal point. They would accept 0.095 or 0.096. When in doubt, write more. Okay? Don't waste your time worrying about, do I round or not? All right? Just write more if you're ever in doubt. Okay, part D. Using the model G defined in part C, that's our Y1, find the value of G prime of 140, and then interpret the meaning of your answer in the context of the problem. So G prime of 140. G is in my Y1. I'm certainly not going to do that by hand. I'm going to let my calculator do it for me. So math 8 of Y1 at 140. Okay, so they would have accepted 0.004, 0.005, or anything else after that. All right, now, what is the meaning of that? Well, G is the rate of flow of gasoline in gallons per second. So what is G prime? It is the rate of flow of gasoline, right? If G is in gallons per second, then G prime would be gallons per second. Or you could write that as gallons per second squared. Okay? So, we have to give the meaning of the time, right? So I like to start there. At 140 seconds, the rate of flow of gasoline, that's what G is. That's just G. The rate of flow of gasoline is changing at a rate of G prime of 140 gallons per second per second. Okay? You could write that again as gallons per second squared if you want. You can write it as gallons per second over seconds if you want to. There are a couple of different ways that you could write that, but it needs to be there. Okay, remember nut. This is another nut one. Noun. Rate of flow of gasoline. And it's another rate involved. It's the rate of the rate of flow of gasoline. They need to see two words that say rate, all right? We could have said the rate of the rate of flow of gasoline. Okay, something like that. There needs to be two rates. Units. Units on what we're finding and units of the 140. Both of those. Time. 140 seconds. Alrighty. Let's see how they scored that problem. So let's see. Part A. Part A was worth 3 points. Where can I put this? Part A was worth 3 points total. 1 point was for the interpretation. With units. 1 point was for the form of the Wright-Riemann sum. They probably allowed for one or two typos, okay? But the form needed to be there. And then 1 point for the answer, the approximation. 3 points for part A. Part B was worth 2 points. 1 point was for saying that f of 120 minus f of 60 was 0. So you guys, when you're doing this, you need to show that. You need to show this part and this part, the values from the table and what their meaning is, okay? Don't just pull values from the table without saying what they mean. Because if you just show this, you guys, we don't know where those came from. There are two of those. Which one was which? Show both. You must show both. To get this point, you need to show both. And then 1 point for your answer with justification. So 2 points for part B. Part C was worth 2 points. 1 point was for the average value formula. 1 point was for the answer. And then lastly, part D. 1 point was for G prime of 140, that value, and then 1 point was for the interpretation. Okay, so that was that one. That's this topic. I think it's a good topic. Usually it's a pretty strong topic for us. We've been doing this for a long time, so hopefully that will be a strong one for you.